All right. Lesson 1 for robotics for the older kids curriculum. So that's going to be grades 3 and up. So for lesson 1, we're going to be using our circuit boards. We're going to have these out. And in our kits, we should have about at least 5 of these because we're going to partner them up into groups of about 3 per circuit board. So let's get right into it. All right, so the first thing you guys are going to do for this lesson is you guys are going to run a discussion about circuitry and circuit boards. So the first thing we'll say is introduce the idea that today we're going to be working with electricity, right? We're going to be working on creating a complete circuit with electricity, and we'll talk about what are circuits. We're going to explain that in this class we'll be engineers, right? Because this is day 1, so we want to set the correct framing for the class moving forward. So in this class, we're going to be engineers, robotic engineers, sometimes architects as well. But throughout the class, we're going to look through the frame or the lens of being an engineer. We'll ask them questions like, how do engineers work together? What is electricity? What does it do? And these are the questions we'll pose at the beginning of class to get the kids thinking. All right, so we'll start to hand out the circuit boards, and as we do that, we're going to put them into partners of 2 or 3 max. So that's why you want to have at least 5 circuit boards for your groups. So when we get them into partners, they're all going to have a circuit board. They're going to have a booklet, a board that looks like this, and a bag that should have all the materials shown in here. So when each group gets that, we're going to begin by explaining to them what is a closed circuit, an open circuit, and a short circuit. Okay? Right, so the first thing that we'll do is we'll demonstrate these concepts. So we'll ask everyone to get out their battery pack, which looks like this. I'm going to turn the camera down for this part. So everyone's going to get out their battery pack from here. I usually keep it in a separate bag just to keep it out of the way so that it doesn't accidentally turn on any other equipment. Battery pack right here. We'll have our blue connector pieces. They're going to need 2 of these pieces, 3 pieces. So the battery, 2 of these, and the light bulb. All right, first thing that they'll do, you're going to show them how you can place your battery onto the board. So like so, I'll place it right here, click it into place. I'm then going to put my light bulb with a row in between in between it and the battery pack. That's going to allow me to connect it on this side with the 3-piece and on this side. We're going to explain that these function the same as any kind of wire. All these do is allow electricity to pass through them, right? We put this connected. Now we have electricity. So we explain to the students, this is called a closed circuit. A closed circuit allows for the flow of electricity, so it allows the light bulb to be powered on, and it allows it to stay powered on. If we take off one piece, we'll have everyone do this together in their own boards. They'll take off one piece. Now we have an open circuit, right? So an open circuit is not complete. The flow of electricity can't be continuous, and so it can't power on the light bulb. We'll explain to them after that by taking one 3-piece, which is again just a conduit for electricity, and placing it onto the battery. We explain that this is called a short circuit. The electricity is flowing into itself without powering anything, right? If you were to take a copper wire and connect it to the top and the bottom of a regular battery like this one, what would happen is the battery would start to overheat. In this case, these have safety regulators to prevent them from overheating too quickly, but still what this would do is eventually overheat or kill the battery and take away the ability to produce more electricity. So we have open circuit, closed circuit, and short circuit. After that, now we're going to get the students to start using the booklet, and they're going to go for today's lessons from projects 1 through 5. All right, so we'll open up the booklet, have them all check out together project 1. And what is project 1 asking us to do? It's going to be asking us to use the battery pack, the 3-piece, and connecting the light bulb, but this time using a switch so we can turn it on and off. So we can explain to the students that before, when we powered on the light bulb with the 2 connecting pieces, the light bulb would stay on as long as they were connected or the battery was still had energy. But there was no way to turn it on and off except for disrupting the entire circuit. In this case, we can change things, and we'll do it as the book shows us, right? So I'll have my battery pack down over here. I'll put a 3-piece over here. And the book is showing me a specific way to do it. You guys will notice there's a grid. On the top, there's letters. On the top there's numbers. On the bottom, on the side, there's letters. You can use those to match it up exactly how the book shows you as well, right? And those same things are also on the on this board as well. So we'll plug in the light bulb how it shows us. Right, they've got it facing this way, so I'll flip it. Plug in the light bulb as it shows us right here. Put in the slide switch. There's 2 kinds of switches in each bag. There's a slide switch and a button switch. You want the one that switches from on and off. So we'll plug that one in right over here. Turn it on. Now we have electricity that we can control by opening and closing the circuit, right? Open circuit, close circuit. This time we didn't have to remove any wires. So then right after that, they'll go straight into project 2. Project 2 is going to have them now using simply a different color light, seeing how they can power on something different, right? For this one, it's important that we actually match it up the same way that it shows us in the booklet, because if we don't, it won't power on. So the positive side right here has to match up to the positive side on the battery pack over here, which you guys will see when you're using the kit. So when I match them up like this and I switch it on, what we get is a light that's been powered on. However, if I flip it and face it the wrong way and turn it on, it won't work, right? For some items in this kit, that's the case, and for others, it's not. So that's why I recommend the entire time when using circuit boards, we focus on setting everything up the way that the book demonstrates. Awesome. Within Project 2, and you guys will see this in your booklets, this is reversed, I won't show you, but within Project 2, there's a Project 3, right? It asks you to replace the 3-snap wire, meaning this one, with the photoresistor. If I were to do that, and put the photoresistor right here, and then put everything back the same way that it was, right, with the slide switch right here, oops, and our multicolor light right here, you'll notice something. When there's no light in here, the light doesn't power on. When there's a lot of light going into the photoresistor, like this, the kids will actually see the multicolored light start to light up as well. So what the photoresistor is doing is it's detecting light. When it detects a lot of light, it turns on this light bulb. When it doesn't detect a lot of light, or it detects no light, there's no power to the light bulb. All right, so throughout this course, or using this kit with the students, they'll have different options or opportunities to use the photoresistor, and they can keep that in mind. You can also teach them how might this be helpful in real life. You could think about the opposite idea is, with this one, when it receives a lot of light, it powers on the light bulb. If we think about street lights, if they detect no light, then they power on the light bulb, right? So that kind of technology of using a photoresistor can work in ways to make things a lot easier, right? So we have Project 2. Project 3 is going to be very similar. We're going to go straight to just switching this we're going to switch this back into our 3-piece. And then we're going to be using our motor now. The motor, the same thing. You have to make sure you're matching up the correct side to the battery. It has a side that says positive and a side that doesn't say positive. So we'll match up. In this one, it's asking us to match the positive side towards the blue piece. So I'll do it just that way. I'll put on the switch over here. It's already on, so I'll switch it off. And now they can take the hoop, place it on top, and we'll see what happens. And for this one, it's asking us actually to use the press switch. So I want to use the one with the button. I place it right here. When I press it, it starts to spin. When I let go, it stops. For Project 5, it's simply asking me, it's within Project 4, it's asking me to flip these. So I flip the fan to face the other way. And now we'll see what happens. Right, you've got to fit it between the 3 pieces, press the button, and then when you let go, it'll stop spinning. All right, so it can go both ways. Finally, they're going to go to Project 6 if they have time, which is where they'll first use the audio. However, in most of my cases, they get up to Project 4, and usually the class is over by then. okay? I will demonstrate project 6 briefly, and we'll finish with that one. So for project 6, when we're using the speaker, now we really have to make sure we're matching up everything exactly how it shows. So I'll just kind of demonstrate it here, since you guys can't see the booklet properly. I'm going to match up the battery pack how it wants. This corner right here should be on C4. So I look for, with that, I look for C over here. I look for 4 over here. I connect it. Next thing I'll do is I'll get out my connecting pieces that it wants. So it's asking for several. I need a 5-piece. That's going to go from A1 to A5. I need to connect a 3-piece right over here. I need to place the green brick right over here. This is going to give us the soundtrack that our speaker will be able to play, right? So I'll connect another 3-piece over here, just following exactly how the book shows me. And I'll connect the final 3-piece and place my 4-piece over from F1 to F4, connecting over here. Now it wants me to include the press switch and the slide switch, so I'll do just that. The press switch on this side right over here, facing the way that it's asking me to, and then the slide switch over here. And finally, I think all we need left is our speaker. So I've matched it exactly how the book shows me, and I've even layered it correctly, right? The 5-piece here had to go at the bottom so that these ones could stack on top. If you guys can see the layering in the board. Now I'm gonna just take the speaker, I'm gonna connect it from this corner to here for my final piece. Making sure everything's off. If I turn it on and press the switch, it should work. Now we have to check and see what are we missing, right? Everything looks connected. Slide switch, press switch. So more often than not, this only happens if at least one thing is off or one thing is missing in the project. So we'll see. There's no reason this one should. Ah, there it is. Right, so it's just as easy for myself to miss something as someone else. I was missing the 2-piece in the bottom. Now that I connected that final piece, I have the sound. I'm not gonna play too much because I'm in an office here, but that's the gist of getting the audio, right? The reason it wasn't working is I was not seeing one piece in the corner that my grid was showing me, which are sometimes easy to miss. If that happens to the students, tell them no problem. That's why we follow a plan, and that's why we work with each other, right? If somebody misses something, maybe someone else can see something that one of us didn't miss. All right, so that's everything for project number 1, or for lesson number 1 in our older students' robotics curriculum. Awesome.